everyone, welcome back. Welcome back to Satisfactory. It's been quite some time. I was on a very long break. I was on like a month and a half long break. I really needed it. I have been working for like a couple of years now continuously, so I took a pretty long break, relaxed, but now I am back. So yeah, I literally did not play anything. I did not play any games. So yeah, now I am back to playing Satisfactory. So yeah, so with that, I started catching up. I had nearly forgotten what I was working on. There are lots of stuff that I had planned. So the first was this one, Alien Power Augmenter. So which I needed to make Alien Power Matrix. So that was one of the factories that I wanted to build. But I started thinking about it a little bit, and looking at this, it needs like 5 Alien Power Matrix, like per minute, and I need 3 of these. I plan on putting one more over there, so that's the reason it's empty. So which means I need like 15 alien power matrix. And if I search that, alien power matrix is not cheap. It is pretty difficult to make. I need 25 SAM fluctuator, which is I think fine, but superposition oscillators and power shards is not easy. Excited photonic matter is fine, but power shards needs like this is the automated recipe, so it needs like quartz crystals, dark matter crystals, and time crystals. All of this needs like quartz and coal. It's not fun. I don't have it. And then this one. This is just too much for me right now. It needs the crystal oscillator and alkyd aluminum sheet, so I need quite a bit of it. So I don't plan on doing that yet. So I'll just leave that for now. So the next thing that I was planning on doing was the nuclear power plant. So that was one of the huge project which I had. So I started building some blueprints for that. And this was the place. This is sort of like a canyon, which is right next to my base. And this felt like a perfect place for a nuclear power plant, because usually nuclear power plants are built near water. That's the first thing. You need to have abundant access to water. And then this felt like a perfect place because it's in a canyon. So if something goes wrong, you can just blast the entire nuclear power plant and submerge it and basically, yeah, so cover it up. So yeah, so this felt like a perfect place. Even in real life, I felt like this is where you can build stuff. And this is like sort of like a circular shape, and you can also have a pathway like a road on the side over there to the top. So you can build trains actually, which easily from there you can just bring it down. So you can have a train station. But I do want a dedicated rail network for my nuclear power plant, which brings in uranium. I don't want uranium to go through my actual rail network, because that means that means the radioactive stuff is like just flowing in a normal rail network, which never happens. Usually radioactive materials are like safely stored and safely transported and all of that. So I want to have a dedicated rail network with this, but I do plan to take this path to make the railway. So yeah, so with that, so this is the place that I'll be building my nuclear power plant. Everything is good. But most importantly, I started going through all the recipes. So I think in this video, I do want to go through all the nuclear recipe and just go through my thought process of how I'll be doing this. I think most of you will be already aware, or you have already worked on this and are experts on this, but I'll just go through this. So the way that I started was, so I started from the end product. So the end product is the fixonium fuel rod. And I can produce 2.5 fixonium fuel rod and dark matter residue. And dark matter residue, I can just convert it into dark matter crystals, like this one directly, and I can put this into awesome sync. So that's not an issue at all. So if I go back, this is this one. So So if I go back to this recipe, there is only one recipe, so there is no alternate recipe. I don't have to worry about that. So this byproduct is not a huge thing. And it needs fixonium, electromagnetic control rods, fixed site trigons, and excited photonic matter. Electromagnetic control rod is just straightforward. There is nothing over here. It's just raw resources. Fixed site trigon is the same thing. You use SAM and you make it. But the fixonium is the next thing that we need to worry about. So 2.5 fixonium fuel rod. So 2.5 rods per minute. So now that being said, I did cheat a little bit. I went into, I just Googled and checked how much power is produced by fixonium fuel rods and how much it's consumed. Because that's one thing I was not able to find. Like you can build the nuclear power plant, but this does not tell you how much of consumption it is. You can see water consumption, but that's it. So you cannot see how much fuel is burnt. So yeah, so I just Googled it and I checked. So it's like fixonium fuel rods at like 100% clock speed. It's like 1 rod per minute. So per minute, it consumes 1 rod. And it's at 100% clock speed, right? So if you make it 250% clock speed, you can burn 2.5 rods per minute. And I'll be overclocking this entire thing, at least the nuclear power plants, to 250%. So this 2.5 rods per minute is for one nuclear power plant. It will consume 2.5 rods per minute and it will produce power. And I think it's a lot less. The power production is a lot less compared to plutonium and uranium fuel rods, which makes sense because if you are using uranium or plutonium fuel rods, you produce byproducts which cannot be used at all. So you will have to, yeah, so you have to use the byproduct. You have to store the byproducts, right? So, but with the fixonium, there is no byproduct at all, so it produces a lot less stuff. Anyway, so that's 2.5 rods per minute. Now, if we go back, so for 2.5 rods per minute, I need 5 fixonium. So 5 fixonium. 5 fixonium needs like plutonium waste, 5 plutonium waste, singularity cells, and dark matter residue. Singularity cells is definitely tough. This is I think the toughest part over here because it needs that nuclear pasta, and it's a lot of resources, that nuclear pasta thing. So yeah, anyway, so the 5 fixonium needs 5 plutonium waste. So from fixonium it goes to that, and plutonium waste to fixonium. So now we are at plutonium waste. So if I go back to this plutonium waste, so how much was that? This one was 5, right? 5 plutonium waste. So 5 plutonium waste. Plutonium waste. Oh. Is this the same recipe? Oh, it's showing the same recipe. Anyway, I think plutonium waste, if I can. Okay, it's not showing where it is. Okay, let me see. Okay, so plutonium fuel rods. So if I check the plutonium fuel rod, so this produces plutonium waste when it gets burnt. When it gets burnt, it produces the waste, right? So okay, so this plutonium is also burnt at like 0.1 rods per minute at 100% clock speed. So this was the calculation basically which I did. So 0.25 rods per minute, because everything is per minute, the calculation. So it's 0.25 rods per minute and it produces 10 waste per minute. I think I Googled this because I was not able to get it from this. Yes. Now I try to find this. I was not able to. Okay, I have Googled this. So it's 10 waste per minute for 0.25 rods per minute. So if this is 10 waste per minute, I think that is twice what I need, right? Because I need 5 over here. So I'm producing 10 over here. So this can actually run 2 nuclear power plants. So just this 0.25 rods per minute can run 2 nuclear power plants. So if I have 1 plutonium rod per minute, I can run 8 nuclear power plants, which is insane. Yeah, so that's 8 nuclear power plant, which is a lot. So now the plutonium, I need like 0.25. Where is it? Plutonium fuel rod. So it's at 0.25 rods per minute. So the 0.25 needs encased plutonium cells at 7.5 encased plutonium cells. The rest are fine. Heat sinks, I don't have a factory at all for this. I need to make this. So yeah, encased plutonium cells, it's like 7.5 per minute. Okay, so now if we go back to encased plutonium cells, this is the recipe I'll be using, which is non-fissile uranium, which you get after burning uranium rods. So if I go here, so even here you have to burn the plutonium rods to get waste, which means over here if I burn 8 rods, 8 plutonium rods, I will have enough waste to make the fixonium rods and use that. But in order to make the 8 plutonium rods, which is over here, let's just look at 0.25 for now. Yeah, so in order to make 0.25 plutonium rods, I need the 7.5 encased plutonium cells, and in order to make 7.5 encased plutonium cells, I need 56.25 non-fissile uranium. You get this uranium after burning uranium cells. So that's the next one, which is burning uranium cells to get uranium waste, fissile uranium waste, and also doing the plutonium cells. So you'll basically make plutonium rods while also making uranium waste and make plutonium rods using both the recipes. So basically this encased plutonium cells, you'll use both these recipes. So you'll use the plutonium pellet to make majority of the plutonium cells, and with the non-fissile uranium that you get from the uh, uranium power plant, you will make even more plutonium cells. So the plutonium pellet also uses the non-fissile uranium. So you'll also use that, while this is the only way. Oh, this is the only way you can do it. So you'll use the uranium waste and non-fissile uranium, both of these. I think this is not the waste, right? Yeah. So this one is uses waste. This one is non-fissile uranium. This also uses waste. And this waste, I think, does it tell you how to get? No. So this waste, you'll get it only by burning uranium rods. So each uranium rod that you burn per minute, it will generate like 50 waste per minute. So it's like a convoluted thing, but at the same time, it is pretty simple. You burn uranium rods, create power. The waste that you get, you'll convert it into, so that's the uranium waste, right? So that's the uranium waste. So this uranium waste, you will convert it into non-fissile uranium. And this non-fissile uranium, you'll convert it into plutonium pellets. And this, okay, so this, I have an alternate recipe also. Okay, I can use either of these, either the first one or the third one. I have not decided which recipe to use. I have to take a much deeper look into this. This uses uranium and waste. This uses just waste, but it uses silica. Interesting. It also uses nitric sulfuric acid. I mean, this one uses more sulfuric acid, which means I need more sulfur for the alternate recipe. Anyway, I will decide that. But the uranium waste, you'll make uranium fissile, non-fissile uranium, while also converting the non-fissile uranium plus waste. Again, you'll use waste here to make plutonium pellets. I guess that's the most convoluted thing in this whole thing, because this waste, this uranium waste, you'll basically convert it into non-fissile uranium. But in order to make pellets, you'll use non-fissile uranium plus back this waste. Again, you'll use that waste to make that. Then you'll make this plutonium, what is this called? Encased plutonium pellets using this plutonium pellets. Plus, again, there is an alternate recipe which uses the waste. So you'll use that. And then finally, it's a straightforward recipe to make plutonium rods. But then you'll have to burn it to get waste. That waste you'll make fixonium and fixonium rods. This one you'll just burn. So you will have this nuclear power plant which is burning uranium rods, plutonium rods, and fixonium rods. So which is pretty interesting. Honestly, I think this might be the most complex factory, maybe, because it's not straightforward at all. You have to juggle through multiple things, and if you want to make it like perfectly balanced, I will definitely make it perfectly balanced. You will have to fiddle through a lot of these numbers, make sure nothing gets wasted. So yeah, but yeah, I have looked at the numbers. I have already noted those down. I won't be making like a huge like max amount of like using all uranium making a power plant, nothing like that, but it will be a pretty substantial power plant, enough to power everything in my base like when turned on. So it will be pretty substantial. So yeah, so this is a lot, honestly. So yeah, so just to make the 2.5 rods fixonium rods, you actually have to do quite a bit. So yeah, anyway, so this was a very short explanation of how you can set up your nuclear power plant. It's a lot of you do have to use a lot of awesome things to create lots of like fallbacks. What if something goes, what if this backs up, what if this backs up, what if this backs up? Like, you need to ask that question for every single one of your factories, like in individual factories, when you go through the building, and create a fallback loop. And honestly, you can do it a lot easier now because you have the priority mergers. Because using a priority merger, you can put it into an awesome sync and make one singular belt as a priority, making sure that it always goes through. The others can just back up and you don't have to worry. And in case something goes wrong, at that point, everything will start flowing, right? So anyway, so this priority merger can also be used pretty well. Or you can use multiple mergers and get the same output, or you can use one priority merger. You can use either thing. So yeah. So this is a brief explanation of nuclear power plant, and I'll start building this. And I will not force myself to make a video next week or every week from now. I will make a video when I have significant improvement to my base. Once I have made significant advancement in my nuclear power plant, that's when I'll make a video. I won't make a video for the sake of it. I'll only make the video if I think it's worth it, and only if there is significant improvement and advancements in my base. So yeah, so with that, I think I'll close out this video. So thank you, everyone. I know it's been like 1.5 months now, or nearly 2 months. I was on a very long break. I really needed it. I have been working for a couple of years now continuously, so I really needed the long break. But now I'm back with a lot more energy. And I'm back to finally playing Satisfactory. So I really miss the game. So yeah, so with that, thank you, everyone. See you guys in my next video. Bye.